Okay, let's take a look at question 3. Okay, so for question 3, right, we are given the mass of a radioactive substance present at time t after first being observed is given by the formula, where m naught is the initial mass, k is a real number. It takes 35 days for the mass of the substance to reach half of the initial value. Highlight for me important keyword, 35 days. Mass of the substance, half of initial value. Okay, after 40 days, the mass of substance present is 40 gram. Okay, so if you take a look at the equation, I think we have done this similar in our tutorial, okay, whereby you see there's a lot of unknown. Okay, for example, m being unknown, m naught, k, and t. So there's basically 4 alphabet there. Okay, but can you see that in this question here, they are very nice. They define for you m naught is the initial mass. Okay, so if m naught is the initial mass and I given that 35 days later, the mass reach half of its initial mass. So agree with me, this highlighted in green will tell you that mass of the substance is defined by m, okay, and it reached half, so therefore it will be half of m naught, okay, at t equals to 35, just based on this first statement, or just based on this statement itself, okay, and my main aim is to show that k equals to following expression, so therefore I'm going to use this information m equals to half m naught, t equals to 35. Plug inside my equation. Okay, the rest is just simplification. So cancel my m naught on both sides. M naught cancel on both sides. Okay, you reach this. Okay, aim is to have k. So therefore, I need to make k the subject. Okay, so to make k the subject, see that this part here, I have my k at the power. So if k at the power, if I want to bring it down, I have to take ln and log on both sides. So therefore, I'll take ln. Okay, now do me a favor for showing question, never jump your step. Okay, so the moment you jump your step, right, marks will be deducted. Okay, so once you take ln on both sides, okay, this part here, we have just do our recap, right? Okay, to go down to the next line, okay, recall. Okay, if I have anything power, I can always bring down the power to the front. So this is by recalling. Okay, and at the same time, we have actually ln E is actually log E, which will give me to be 1. So making use of these two information, I have ln half equals to minus 35k. And of course, make k the subject. Okay, now part 2. I want you to highlight the important word, z. Okay, when a question asks for z, which means you cannot use your GC and you must show all the working. Okay, and I want to find the exact value of the initial mass, which means my main aim, find m naught. Okay, as I want to find m naught, let's look back at the question. What do I have? Okay, my main aim is to find m naught. Okay, so if I want to find m naught, okay, see that I have to fill in my m, I have to fill in what is my k, and I have to fill in what is my t. Okay, I need all these three. Okay, so do I have three information? Okay, which in particular, m stand for the mass at time t. So can you see I have this particular information? After 40 days, my mass is 40 gram. So therefore, I have m equals to 40, t equals to 40. Okay, and do I have a k? I have my k, which is from the previous part. So all I need to do, just sub it in. Okay, so allow me to show you, sub it in. Okay, so this will be what you get. Okay, with your k being sub in, make m not the subject. Okay, now because the answer 1 exact, right, which means you're expected, and take a look at the marks, there's 3 marks. Okay, you cannot just stop here. Okay, so you have to simplify your working. Okay, so simplify my working, allow me to carry on first. So once you simplify, you reach this. Okay, now which we cannot still stop here, because if you take a look at your power, okay, your power is something, sorry, exponential to something power. It's something we can simplify. Okay, so in particular, the things that we want to simplify, okay, recall that in our tutorial, if we have this property, okay, whereby my base and this is the same, right? This will be just equals to a. I hope you still remember this that we have in our tutorial. Okay, similarly, if we have something, let's say, give me a minute, a log a b. This one, because they have the same base, okay, they will eventually become just b. So this thing here will be your b. Okay, I hope you still remember this that we have in our tutorial. Okay, so we want to make use of this because I see that I have E and this Ln. Okay, but what is obstructing here is the 8 over 7. So again, okay, my this 8 over 7, if I go to recall another one, I will have A, Ln, B can be given by bring out the power. so that I do not have the 8 over 7 obstructing me. Okay, so I'm going to bring out the power. Okay, over here, I'm going to use this property. Okay, so eventually I will have half to the power 8 over 7. Okay, but we still cannot stop here because we cannot have fraction over fraction. Okay, so therefore simplify your denominator. So I'm going to work with my indices. Okay, so if you work with your indices, basically focus on my denominator. Okay, your half can be written as is half 1 plus 1 over 7. Alright, which will be given by half times. Okay, if you recall your indices says that if it's A, B, AC, you will given by A, B plus C. When it's the same base, you just add up the power for multiplication. Alright, so therefore we are just working the reverse way. Okay, why do I want to use this? Is because I want to have a very nice number, because you see that it's 8 over 7, which means I have a whole unit there. Okay, so I'm going to use plus instead, okay, as 1 plus 1 over 7. Okay, from there, simplify my working further. Okay, I have my 40 divided by my half. That's how I get 80. Okay, still a fraction, so change it not to be a fraction. Eventually, you get this. Okay, the next part, let me just pause for a while first.